The Dynamic Learning Maps Alternate Assessment System is a new assessment designed to more validly measure what students with significant cognitive disabilities know and can do. This presentation is on composing, decomposing, and comparing numbers, and will provide information on this topic to teachers of students with significant cognitive disabilities who will complete the alternate assessment. This training is one in a series of training videos that supports teachers of students with significant cognitive disabilities in their efforts to teach and assess. Sponsored by a grant from the U.S. Department of Education, Office of Special Education Programs, this training is part of the professional development efforts of the Dynamic Learning Maps Alternate Assessment Consortium. Please note that it would be helpful to you to have participated in the unitizing, units and operations, the power of the tens frame, and the place value modules prior to participating in this current module. We have discussed composing and decomposing in other DLM modules because it is such an integral part of so many math concepts and operations. As a reminder, composing refers to combining small numbers like 4 and 5 to form a larger number such as 9, using addition. Decomposing involves expressing a number as a sum of two smaller numbers. For example, 7 as 3 plus 4. And a single number can be composed or decomposed in many ways. 2 plus 3, or 3 plus 2, can be composed into 5, along with many other representations of 5, including 1 plus 1 plus 1 plus 1 plus 1. Or 5 can be decomposed into 2 plus 1 plus 2, or any other combination of 5. Composing and decomposing numbers builds a foundation for understanding number grouping. This idea of grouping is an important concept and will be used across the grades. It carries over into understanding numbers, as well as understanding the place value system, and later into algebraic concepts. Understanding the number 7, or any number, and flexibly thinking about how to decompose it will bring meaning to the other operations we require them to learn, such as 4 plus 3 equals 7, or 7 minus 4 equals 3. The photo on the right is an example of place value and shows the number 143 as a group of 100, a group of 40, and a group of 3. We can change the number by changing the group. Add 2 ones to the 3 ones, and our number changes to 145. Or add 10 ones, or 110, and the number changes to 153. Students need a lot of experience working with groupings, first with small numbers and then with increasing quantity over time. Pause for Activity 1. After students can work with quantities as large as 8, as in 8 plus 5, then they can decompose the 5 into groups of 2 and 3. Then they can combine the 8 and 2 to compose a 10 and add the 3 remaining to compose the value of 13. What this means is that the student no longer thinks about 8 plus 5 as 8 plus 1 plus 1 plus 1 plus 1 plus 1, but rather can move to the tens work as illustrated in the diagram. When students understand that composing and decomposing make many types of calculations much simpler and more efficient, they are much more likely to utilize the skill. Take, for example, the symbolic problem of 15 minus 8. Students decompose 15 into 10 ones and 5 ones, minus 8 ones. When they set the problem up in this manner, it's much easier for them to take the 8 ones from the 10 ones and then add the 5 ones to derive an answer, because at this point they have a lot of experience working with groups. Carrying and borrowing, which are regrouping procedures, really are the same thing as composing and decomposing, but composing and decomposing seem to be less confusing to students than carrying and borrowing. When you borrow the 10 from 15 and make it 10 ones, it still looks like the number 15, and students struggle to understand that they have changed anything. Being able to compose and decompose helps students understand addition and subtraction rather than memorizing a process, which then doesn't help them when they need to apply the knowledge to later math concepts. In this module, we are moving from composing and decomposing numbers to comparing numbers, but it's an artificial sequence. These concepts can be intertwined. For example, let's look back at the problem 15 minus 8. At the beginning of the lesson, a teacher may choose to start by having students compare the numbers to figure out which is more, and then move into composing and decomposing the number 15, finding the answer, and then going back to compare the answer with the number 15. It's a subtraction problem, so students should think about the question, would the answer be more or less than 15? And then check, is it more or less? But how do we begin comparing numbers, and where does it lead? As in the unitizing module, instruction may begin with same and different. If needed, start with same. It is a concept that is often grasped earlier and more easily. Keep it fun as you sort and divide objects into groups. Focus the student's attention on different properties such as color, shape, or size. Materials are almost limitless as long as you have more than one. Consider materials that are distinctive in nature, for example, color, shape and size, and texture. Consider the student's visual abilities when deciding what objects to start with. For instance, if a student does not have vision issues, a teacher may start with the concept of same using color. If they do have vision issues, use objects that have distinctive visual features or textures, such as a ball with flashing lights, or object wrapped in something furry, silky, or scratchy. As you talk with your student, tell him or her that the objects are the same color or texture. For students who are deaf-blind, depending on the severity of the condition, you may use hand under hand to explore the object and sign the word same. Emphasize the word same. As the student enjoys and explores the objects and interacts with you, pick up another matching object and ask the student to give you the object that is the same. Wait a bit to give the student time to think. If he or she needs help, provide assistance while continuing to keep the activity fun. Pick up another appropriate object and show it while telling the student they are the same. When your student is familiar with the concept same, it's time to begin working on different. Follow the same strategy used with same. As the student is learning to generalize the concepts of same and different, quantity should also be one of the characteristics introduced. Pause for Activity 2. More and less are the next concepts to be introduced. Instruction may begin with making comparisons between non-countable items such as juice or sand, and then move to countable items such as animals, chairs, tiles, and cubes. Students should determine whether one quantity is more or less than another. The difficulty of the comparisons can be adjusted by changing the type of question we ask. The students can compare two groups of varying sizes, and the teacher may simply ask, "Is it more or less?" pointing to one of the groups. The difficulty of the task can be increased by asking, "How many more?" and "How many less?" And eventually we will ask questions like, "What can we do to make both groups the same? What is the difference between the groups? How many extra books are there? And how many dogs won't have leashes?" Other factors also contribute to making the activity easier or harder: the size of the group, the difference in the quantities, and how the tasks are presented to the students. The instructional goals for comparing quantity are comparing groups to determine which is more and which is less, creating groups that are more or less than a given quantity, adding or taking away from groups to make the groups the same, indicating the difference of amount between the two groups, and ordering the quantities. As children gain knowledge and skills in comparing quantities, the size and difference between groups become greater. This knowledge will be used across the grades and mathematical areas, such as sets, fractions, ratios, data, geometry, measurement, time, and algebraic thinking. And therefore, time should be given to allow students the opportunity to understand the relationship between quantities. In the module, The Power of the Tens Frame, there is information about how to use the 10 frame to build an understanding of number. We want to reiterate here that the 10 frame can also be used to help students compare quantity. Look at these two quantities. The first has 6 dots and the second has 9. The use of the 10 frame will help students conceptualize which has more, which has less, and what's the difference. Greater than, less than, and the respective symbols are also important concepts for students to learn. By 5th grade, the DLM essential elements convey the expectation that students will compare whole numbers using the greater than, less than, and equal symbols. And it is important to note that these words and symbols are unique to the math content area and therefore are not included in a student's core vocabulary. So for students who use augmentative and alternative communication systems, how and where do we give the students access to this vocabulary? The answer is, we incorporate the symbols into the student's number line. An example can be seen here. Because of this, students can and should be exposed to this language and the symbols prior to the 5th grade when they will be asked to use them in context. These symbols can be introduced with words more, less, and same. The students who are using the DLM core vocabulary set, teachers could model the words and symbols more and not more for greater than and less than, and not different for same or equal. Thank you for participating in the Composing, Decomposing, and Comparing Numbers module. For further information, go to www.dynamiclearningmaps.org.